So this is for any of our friends who were out on Wednesday, and this is also for anybody who may have missed something in the very rich discussion we had. Well, first we went through how to evaluate the derivatives of functions at a point, and we need to hit on our calculator math 8, and we'll come up with n derive. We put in our function of x, and if it's a function of x that we're deriving with respect to x, we put the next thing we put in x, and then we put in the point. So here g prime of 4, if the function is x squared, we want to use put our functions x squared, and the point would be 4. Okay, the next one is f of x is equal to cube root of x. Watch my other video of why this 100 answer kind of really made me upset and made me have to make the last video. So in class we discussed differentiability, and we looked at this graph of x to the 4/3, and we want to look at a point x equals 0, just like we classified discontinuities at different points. We're going to discuss differentiability at certain points. Is this function here continuous at x equals 0? Yes, it is. Is it differentiable at x equals 0? No. And why not? Because if we take the limit, this is the definition of derivative, definition of the derivative at the point 0. So that's why, let's say orange, that's why this right here is 0. We take this limit as h goes to 0 of f of 0 plus h minus f of 0 over h. If we were to do this numerically, which is the only way we can do it right now with what we have in our abilities, we would find that this doesn't exist. And it doesn't exist because if you do it numerically, if you take this limit as h goes to 0 from the left, and you take the limit as h goes to 0 from the right, you'll see that they don't equal. So this as a cusp, and we also have to specify at what point. This is a cusp at x equals 0. Okay, next one. And if I'm going too fast, you can always pause me. If I'm going too slow, you can rewind me. So what about this one? We have y is equal to the absolute value of x, and we're looking at x equals 0. Is this continuous? Heck yes, because if we just take our pencil, we can never leave the paper while we draw this function. Is it differentiable? Sadly, no, it's not. For the same reason as the last, the limits from either side are not the same. And we also said, we caught somebody with this one. We said, is it differentiable at the point x equals 2? And it is, for sure. I mean, we can find the slope of the tangent line there. The slope is just 1, right? And what's the derivative? Well, instead of spitting out the answer, well, the derivative is just equal to 1. A lot of people would have made the same mistake our friend made when our friend said the answer is 2. Well, no, it's not. The slope is 1. So come on. Okay, let that sink in. Maybe pause or yell shut up at the screen and then hit pause. What about this one here? Y is equal to the x to the 1/3 power, so the cube root of x. Is this continuous? Yes, you can look just at the graph and you can see it is continuous. Is it differentiable? Sadly, it is not. If we take the limit of as h goes to 0 of x plus h to the 1/3 minus x to the 1/3 over h, we would, if we did it numerically using smaller and smaller h's, we would get infinite. We'd get an infinite answer. No matter, keep getting a smaller h, you're going to get a larger number. And there is no slope of a tangent at x equals 0. If we drew a tangent line right there, it would look. What do we draw tangent lines in? Green. It would be right here. It would be the y-axis. It would be the line x equals 0. So this has there's a lot of different names for this. It has an infinite or it has a vertical tangent, so it's not differentiable at x equals 0. And maybe I didn't put at x equals 0 for the last one, but you always have to say if it's not differentiable, we're talking about a certain point. Okay. We are motoring here. I hope this is helpful for our friends. So let's look at this. I misdefined the function. I used a different function in class. I'm going to have everybody go back and fix their notes and use this function, because the function I used, I had no right to draw on the board the way I did, and I apologize. But this is the better function to consider. Y is equal to 1 if x is greater than or equal to 0, is equal to negative 1 if x is less than or equal to 0, and we look at the point x equals 0. So we're right here at the origin. And where are we? What's the is it continuous? No, it has a jump discontinuity, so that's why I wrote no here. And is it differentiable? No, it's definitely not differentiable. Where's this? What slope? Tangent line? What? Come on, you can't draw a tangent line here to this. What are you going to draw? A line like that? No, we draw tangent lines in green, right? You're going to draw it like that. Are you going to say, oh, the slope over here is 1, and the slope over, I'm sorry, 0, and the slope over here is 0, so the slope of the line tangent at x equals 0 equals 0? No, it's not continuous. You cannot find the slope of the tangent line for a discontinuous function. So we have a discontinuity at x equals 0. Again, you might want to let that sink in. I can't see you if you look confused. Okay, good. Now I got this part. So we took the next point, and considering the last one, we said if it's not continuous, we can immediately assume it's not differentiable. So we can't find the slope of a tangent line when it is not continuous. So it's, like I said, it's not differentiable. So thought about this for a second. Some people kind of pick this up right away. We're talking if it's not continuous, it's not differentiable. We want a more positive statement. As a matter of fact, we want the contrapositive to this statement. If it's not continuous, it's not differentiable. So after a little bit of discussion, this is logic. If we thought of an example of a fish, if we're not a fish, we are definitely not a shark. Okay? So the saying the same thing. If you are a shark, you are definitely a fish. And I drew a little shark over here, so get out of the water. So differentiable implies continuous. We cannot go back the other way. We cannot say if it's continuous, it's differentiable. And we look at the first 3 examples, I'm sorry, example 1, 2, and 3, to see that we cannot go this way. This continuous does not imply differentiable. Just like to look at the fish and shark example, just because you are a fish doesn't mean you have to be a shark. Okay, that's I know there's a lot of words there. If you're afraid of sharks, I may have lost you there. Sorry. I only had 9 minutes, so I hope that was helpful.